What are some of the challenges associated with data acquisition in mass spectrometry? In this video, we focus on selected problem areas and explain how these can be resolved by selecting digitizers with the right feature set. We then conclude with a more elaborate list of digitizer selection criteria for mass spectrometry systems. Mass spectrometry data acquisition challenges include space constraints and signal reflections, signal conditioning for dynamic range optimization, baseline drift, and distinguishing weak and rare signals in the presence of noise. Teledyne SP Devices' extensive experience in this application area has allowed us to create unique solutions that help simplify high-performance mass spectrometry system development. We will now take a look at some of these techniques. Even a minor impedance mismatch between the detector and the digitizer can result in signal reflections propagating back and forth in the cable. The superimposed reflection, also referred to as a ghost signal, is incorrectly interpreted as ions hitting the detector, giving rise to false readings. The problem gets worse with long cables between the detector and digitizer, and the digitizer should therefore be co-located with the detector for optimal results. Space constraints and signal reflections challenges are resolved using compact standalone digitizers such as USB 3. These fit within the mass spectrometer enclosure and are located close to the detector to minimize the impact of reflections. Our FPGA firmware solutions help reduce the data rate to match the USB link capacity while ensuring that pulse information and characteristics are maintained. Digitizers from Teledyne SP Devices also offer features such as hardware trigger output that simplifies ion source triggering and ensures accurately measured flight time. In mass spectrometry, the acquired signal is unipolar and typically has a negative polarity. Large ion signals risk saturating the digitizer input, as illustrated in the red area of the figure to the left. To avoid saturation, the amplitude needs to be lowered, as illustrated on the right. However, this is not optimal, as it leaves the upper part of the digitizer's input range unutilized. Optimized acquisition of unipolar signals is achieved with user-programmable DC offset, as shown to the right. This is a crucial feature, as it allows the full input range of the digitizer to be utilized for larger signals without the risk of saturation. It is common to leave a small offset margin of 5 to 15% to account for potential undershoot. Signal trigger level and pulse characteristics are determined relative to a fixed baseline, DC reference level, and this baseline must be stabilized to high precision. Uncorrected, the baseline is subject to drift over temperature and through component aging. This needs to be corrected to avoid false readings and/or performance degradation. Luckily, there is an easy-to-use solution for this that requires very little user interaction. Teledyne SP Devices' proprietary digital baseline stabilizer, or DBS, helps avoid false triggers and restores correct pulse characteristics. It also corrects for so-called pattern noise that further distorts the acquired signal. DBS operates autonomously and continuously in the background and corrects the drift to a stable target baseline level set by the user. Detecting weak ion signatures in the presence of noise is a mass spectrometer key performance indicator. Digital signal processing techniques can improve the signal-to-noise ratio, but such solutions need to resolve rarely occurring signals so that even a weak mass-to-charge ratio can be accurately determined. The first step towards capturing weak signals in a noisy environment is to select a 14-bit digitizer with a sufficiently high sampling rate. One example is the 14-bit ADQ7 digitizer with a 10 gigasamples per second sampling rate. Real-time digital signal processing helps improve the signal-to-noise ratio even further and simultaneously reduces the digitizer output data rate. Digitizers such as ADQ7 can produce up to 20 GB per second, and data reduction becomes an absolute necessity. It ensures robust continuous operation and simplifies subsequent post-processing. Our primary solutions for mass spectrometry include optimal pulse detection firmware, FWPD, that reduces the data rate by discarding redundant data, and advanced time domain firmware, FWATD, that delivers real-time waveform averaging to achieve significant data reduction. Real-time waveform averaging reduces noise, as illustrated to the left. By averaging multiple blue traces, the resulting red trace contains much less noise. A problem with this approach is that rarely occurring signals can be averaged towards zero, hence becoming undetected. This is illustrated here, where two rarely occurring signals are indistinguishable from the noise. Such signals would normally be obliterated by waveform averaging, but by utilizing smart filtering, the rarely occurring signals are retained and easily distinguishable in the figure to the right. Our standalone firmware solutions are sufficient for most mass spectrometry clients. However, digitizers from Teledyne SP devices also feature open field programmable gate arrays, or FPGAs. These can be used to implement custom, real-time signal processing, such as curve fitting and ion pulse extraction. This helps with real-time recovery and characterization of hidden peaks in overlapping pulses. In some mass spectrometry systems, it is desirable to either post-process the data in graphics processing units, GPUs, or record data to disk storage. In both cases, it is beneficial to use peer-to-peer, or P2P, technology that enables direct data transfers between the digitizer and the GPU or storage. This is a huge advantage compared to conventional solutions that place heavy demand on host resources. With P2P, both the CPU and RAM are freed up for other tasks. This table highlights the key digitizer features required for high-ion mass accuracy and resolution in mass spectrometry. Interested to learn more? Then please visit our website to access white papers and additional information. Please contact us if you need help with your mass spectrometer digitizer integration.